Good evening, and thank you all for joining us today. My name is Rashmita, and I'm the event planner for Microsoft Reactor Bengaluru, India. This session will run over the next 60 minutes, including Q&A. The session is being recorded and will be uploaded to our Reactor YouTube channel. I will share the link to our YouTube channel in the chat section soon. Before we begin, please take a moment to read our code of conduct. We are all here to learn together, so please be respectful of other people's views, understanding of differences, being kind and considerate in the way you engage. The chat will be open throughout, and we do encourage you all to participate. Also, please keep your mics muted during the session. I would now like to welcome Dinesh, our speaker for today's session. Dinesh comes with 9+ years of experience around data and cloud, deeply involved in implementing B2B SaaS products for big data and business intelligence. Currently working as product manager for the analytics squad at KissFlow. But for now, I will hand over to Dinesh to begin the session. Over to you, Dinesh.
Thanks for the introduction, Rashmita. Yeah, I'll begin my share by sharing my screen. Okay. So thanks for your time, guys. It's good to see you all at the 6 p.m. And as introduced, I work as product manager at KissFlow for the analytics squad, and also Microsoft MVP for the data platform category. And in today's session, let me just share you about how we can choose a database for our product. The database, what I mean is the backend of our product, right? So when we go with choosing backend, there are a number of options we have as of now. As you all know, the technology democratization has led to make available the best ever features in almost all the products in a line, right? Even in same cloud provider here, let us take Microsoft Azure, different products in data analytics itself look alike. When we just look into the features on top of it, for example, if you take Azure Synapse Analytics and Azure Databricks, both of them do serve the purpose of the kind of big data workloads. That's what it is being projected, but both are different and both serve for different purposes, right? So in this session, let me share my learnings, how we analyzed different frameworks for my internal use case as well, and my learnings through different data products altogether. And I hope that would help you to choose the best database, means the best backend for your product's needs. So this will be the agenda. I'll first of all quickly walk through what a database means, what a data warehouse and what a data lake mean, right? So what is the core difference between these three things? What is the architecture difference between these three things, and in which scenarios each of the best fit and doesn't best fit, right? And then I'll walk you through about a few things which are common, but usability wise different in Azure Synapse Analytics and Azure Databricks. And also I'll also walk through few examples about when to use Azure Synapse and when to use Azure Databricks. And I also give a glimpse of what I myself and my team has faced in this flow while choosing the backend of our analytics module. So yeah. So this is just a quick sneak peek. I hope all of us would have saw this, used this product pretty much after this COVID era. But why I just mentioned here is the front end, which means to access the thing is correct, and the bottom layer, the SOAP itself is also correct, but it is not correctly linked, right? So we just need to be sure that we are not choosing a data tech just because we have resources in our team, or we personally know that, right? And also the world is moving towards cloud agnostic manner. It's not that the AWS should use only based on AWS service or GCP or Azure kind of thing. The world is moving towards agnostic, so and towards the open source paradigm as well. So open your eyes and look widely to choose the best service that would fit for your need. So as a first section, let me just talk about this. And I definitely know that this is a crazy and slightly confusing time in the data architecture space, especially for the data architects, because more and more companies are moving towards data lakes. That is what we hear. But still, the traditional data warehouse and the databases still continue to provide value, as we all know, like it was for decades, around 50 years or 40 years. Now, to add to that, we also have the increasingly popular concept called data lakehouse and the delta lake kind of storage concept as well. So the concepts I discuss in the upcoming 45 minutes would be mostly very common, and also would be even though I talk about the data services in Azure, most of the concepts I used to discuss will be very common, right? So let's dive into deep. And of course, when you're about to choose a database, right, backend, right, and I hope you'd have a similar feeling kind of thing, right? So while we enter a hotel, the need is we are hungry, right? And we need to choose one of the dish to eat. And even though if we choose dosa, there is a number of varieties of dosa, right? We get confused, and even finally we again just choose the plain dosa itself, right? So that's what comes into the picture of the database varieties as well. It is not that always the latest tech is always most essential, that would solve multiple needs, right? So the latest service might fit for some problem. The very old Azure SQL kind of thing might fit for some problem, right? So that's what our angle should be. We should consider based on the problem statement. We should consider database based on the problem statement. That's what I come to say. And and of course, there are there is another major category, whether we need the data to be persisted, or we don't want the data to be persisted. It's two categories, right? If we need the data to be persisted, then it is almost all the databases comes into picture, like Azure SQL database, MySQL, PostgreSQL, and all those things. And if we don't want to need to persist the data, but need to solve some purposes. For example, Elasticsearch, right? Redis cache. These are also called as databases, but it it is not meant to be a database, right? Elasticsearch is a kind of Google search for the data. You can easily imagine with it like that. Every product will be having a search bar, and if a user searches something, it is not going to directly hit the database. On top of the database, there will be something, some software like Elasticsearch or Solar will be there, and it will be providing you the result. So Elasticsearch is not meant for the storage purpose. It solves the application's needs. Okay. So in this session, I'm not going to cover about Elasticsearch or Redis cache. So I'm going to cover uh, the options which we need the data to be saved. Okay. Which we need the data to be persisted. Okay. So first of all, let me start with this database. So anyone from the audience side, could you please explain what the image means in the screenshot? Why I have mentioned this image for the database? Because almost none of us would never be left out without using a database, right? Almost all of us would be using database. So I just want to have an idea what a database is in your point of view. You can unmute yourself, please. Anybody, guys? Okay, it's stored information. Can we have a recap? So I just explained about, gave a brief introduction, and yeah, the main picture is about to start. Vikas Kashyap, sorry, yeah. Okay, the picture shows the way to read, persistent layer, storage and compute. Okay, okay, okay. So what I mean here is the database is the one initially been found, right? It was way old. So it is a single device where a separate space will be there for storing the data. Whatever we enter into the database, it will be converted into zeros and ones, and it will be stored into the data. And there will be separate space. What the space? What I mean is the memory space. Okay, there will be separate memory space. In that, the purpose of that is to accept the requests and to respond back the results. Okay, so that would be the main purpose. So that's what I mentioned here as compute and storage. So here the storage is nothing but the data would be getting stored, and the compute is nothing but it will accept the requests, process over the data based on the request, and it will return the result. So why I just mentioned this image is we all have laptops, we all have desktops, right? It will be having different memory devices. We usually call it as RAM and ROM, right? So ROM is nothing but our hard drive, which is used to store the data. RAM is nothing but used for the processing of the data. Okay, so usually RAM doesn't store it, but it is used to process the data, accept, fetch the data, do some processing, and return the result, right? So this is what the database will be architected. The compute and storage will be tightly coupled together, and if you want to scale just the RAM, for example, you have 1 TB of memory to store the data, and you have 16 GB RAM memory to accept the request and response. Let's consider data doesn't get added much, but you're getting numerous number of requests. 1 lakh requests have increased to 2 lakh requests or 10 lakh requests. It is not possible beyond a limit just to increase the RAM alone. You need to upscale the whole device together to a higher RAM space. Okay, it is a kind of scaling your device vertically. So you have 5-story building, and then you need to increase it as 10-story building, and then you need to increase it as 20-story building based on the number of people who accommodate in. The number of people, what I mean is number of requests. Okay, so that's what the database architecture will be. And the second thing is, if in a database you cannot directly store some data without having any schema. Okay, so what would be the first step while using a database, right? We first create a database, and then we will create a table. While creating a table itself, we will tell that column 1, column 2, column 3, column 4, kind of 20 or 30 columns, so whatever we need. What is the data type each column should be? So we define the schema of that table before we insert, right? It is not possible to execute the insert command first and then create command, right? It is always we need to create a table, and then only we can insert the data. That is what the database is architected for. So when you can go for a database, to choose a database, it's basically very simple. If you have structured data, which you might think over that the the maximum memory capacity would be a terabyte or another terabyte maybe, right? So what I mean by structured data here is rows and columns. If it is of clearly it is of rows and columns, then you can blindly go with go deep to choose any of the database, right? And then if the purpose of the business purpose is OLTP, that is to serve for the product. Okay. For example, if we are using an application and we'll be having a home page and we'll be having a set of options and all those things, right? So to serve for the application where a user can log in and he can add another user, he can do something and all those things, right? So to serve for the application, uh, it is nothing but OLTP. So if it is for that purpose, then directly dive deep into a database. And if it is not, when a database is not recommended, is let's consider there is already a product and it is running on top of a on top of a database or OLTP database, and there is a different need for analytics. Okay, what I mean here by analytics is um, uh, querying with multiple tables, doing the joins, and doing some complex queries. That just think like that, right? So I'm not saying that over a database you cannot query data and produce results. I'm not saying that. If you don't have what kind of analytics you are going to do over a set of tables, then the compute will be too heavy for a database because it is not designed for that. Okay, a database is designed for OLTP, that is to accept more writes, modifications, create and update and delete, right? The CRUD operation, right? So a database is prominently architected for that purpose, and it is not prominently designed for ad hoc analytics, for on-demand analytics kind of thing. Okay, so I'll quickly switch to next thing. So we also have this another big paradigm, right? Data warehouse. So the once in a time the limit has kind of reached, right? There was some need like, okay, we don't have we don't want to increase the storage, but we want to increase the compute alone. What can we do? And there was a kind of need like heavy analytics, ad hoc analytics need to be played over the database system, but it should not affect the product. Okay, in that case, this data warehouse paradigm came into picture, where the compute and storage was clearly separated. So you can easily scale the compute alone or the storage alone. That's how the architecture will be. But however, the data from the data will be restored or copied and stored into its own format while you are choosing a data warehouse. Okay, I'll tell again. In a product, for its transactional need, you need a database, and for its over analytics needs, you need additional something extra. Let's consider you are choosing data warehouse. In that case, the data from database will be copied and stored into a data warehouse in its own format. Okay, so usually database will be in a what a tabular format. Okay, while in data warehouse it is a columnar storage kind of architecture. Okay, and once again, even in data warehouse, there should be schema before you start to insert the data. Okay, and when I would recommend a data warehouse is if you have a clear schema and if you have at least a decent knowledge of how the format of analytics is going to be. Okay, and next thing is, if you don't have much of machine learning needs. Okay, but even though data warehouse can solve the machine learning need, but just consider that you don't have much of machine learning need, right? And another main purpose is usually few products might need to expose the data out to their customers so that they can play over the data on their own. Okay, so for example, let's take Uber itself. Uber has its own data ecosystem, and also also you will find Uber data in public as well, right? We also see many public data sets of very famous products. So that's an example for public data set. But even in a closed product, in most of the B2B products, you might need to expose the data out to the customers, and the customers would like to play over the data, raw data by themselves, or they might need to connect with BI tools to do advanced analytics. In that cases, data warehouse has a decent number of options than database, right? So in this image, you will be able to see that there will be storage, and while a data warehouse is being chosen, again the data will be converted into a different format, and it will be stored, and there will be a separate compute node as well. So irrespective of the storage, you can increase the compute uh, as many as you want. Okay, and when I do not recommend the data warehouses, if your data's nature is like unstructured format, like image or video, right? And if your data has is semi-structured but with too many levels. What I mean here, semi-structured is JSON data or XML data. If the JSON or XML is having one or two levels, then data warehouse might be good enough. But if it is having 7 or 8 levels, then it might not work properly. Okay, so let me go with the data lake. Just consider this as a normal lake. Okay, so if there is a rain in our city, water gets started accumulating different roads, and at one place it starts get accumulated like a pool, right? So the same concept. So in your company or in your product, different spaces, the data might be generated, that might be a file based, or that might be database, or XML or cloud, whatever it may be. And those you want some place all those data to be stored, right? So in that case, you can choose a data lake, and you can just store all those data, fine. So again here, it's clearly the compute and the storage is clearly separated, and even the data is separated, right? So you can independently increase the storage, or have an independent space to increase the compute alone. Okay, and another thing is, in database and data warehouse, you'll be having the schema before you write the data. But in a data lake, you just start to dump all the data into a data lake, and you don't need to worry about the schema at all. It is like you dump all the data, you just store all the data in your Windows drive, right? In C drive, in different folders, you store images, files, and all those things, right? Similarly, you're just storing all the data into a data lake. And while you want to query, you just need to deploy uh, another layer on top of this data lake. For example, if it is a Hadoop, then you just need to deploy Hive, right? And in that Hive, you need to create table, and you can create schema. Okay, so it is totally schema free. That's why it is called as schema on read. And when you can choose a data lake would be if you have different data types, which I mean Excel, CSV, or JSON, PATQA, Avro, different formats, and it is of different sizes as well. It might be GB, or even it might be MB, so different sizes. And if you have some scenario like, okay, I want to store the data now, but I don't want to play over the data. I don't have any analytics needs as of now. Maybe I can play over the data once in a year, or at the end of the year, kind of. Okay, so usually the product analytics data, user behavior data, all these things will be stored somewhere, and at one point, a person like data scientist or data analyst would be accessing over the data, and he'll find some insights. So this would be the nature where the data lake would be chosen for. And when I would not recommend this, again, data lake is not designed for ad hoc analytics, because it is the schema itself will not be there. So without schema, it cannot perform better. So that is one thing. And the another thing is, if your scenario is involved with too many joins, you might have different tables, and if you want to join all of them and do a group by and all those things, then data lake might not be the right choice. Even though on top of data lake, certain services like Hive, they might support join, but internally it is not the actual join like a database doing, right? So because it is not designed for that thing. So that would be a short gap. And if there is any question, you can anybody can unmute yourself and ask, or else I can proceed. Okay. I think Balaji has a question. Application that does not have database is fetching data and showing analytics like Teams and Google Map. Okay. If I assume correctly, Balaji, you're asking that in Google Maps, Google Maps is an application. It doesn't have a database. Then how it is showing analytics? Is that your question? Okay, so it might look like it doesn't have a database, Balaji, but it will be storing the transactional data, right? How what we are using, how we are using all those things. It will be storing in some place. If I'm right, it should be a data lake, and on top of the data lake, some automated service will be running, and that service, what it will do is fetch all the data, and the user behavior data will come from some other service, and it will merge together, and it will produce the insights. Okay, so all those things will be kind of an automation automated only. Okay, so for us, while using a product, we might think that this is just a product, it doesn't have a database, but every product captures the behavior data, especially Google Maps and Teams. I hope that answers, Balaji. And even you can imagine this kind of separation in our day-to-day apps which we are using. Let's consider Amazon.com itself. While you log into Amazon.com, you you just log in as a user, right? You give your username and password. So there will be a database where the username and the password, the credential, right, to match to validate the user. So that itself is a database, first thing. And once you see a landing page, and in that landing page there will be a search bar where you'll be allowed to search for items, right? That search bar will be powered by any of the search databases like what to say, Elasticsearch or something. And there will be some caching database as well, which might be storing your frequently accessed products, and it will be showing there. Okay, so while you just click on that, in a very fraction of a second, it will be opening up and showing you all the details. So that is cache database. And the product list, right? It is not that each product is same. Each product will be having different parameters, right? So a fridge might be having cooling what is the size of the fridge, the temperature, or the number of liters. If it is a laptop, then its configuration is totally different. The RAM and ROM, the company name, the cost, and all those things, right? So the whole product catalog itself doesn't have a fixed schema. Okay, so in that case, it will be a database, but that would not be an RDBMS. It will be a NoSQL database. Okay, that's what I'm going to cover next. So under the database itself, there are two categories. One is SQL database, and the other one is NoSQL database. Okay, so that is one part. And while you are looking out for products, let's consider it as Apple MacBook Pro. That would be a laptop, and immediately it will be showing you the recommended products, right? So which will be so relevant. It is not just randomly showing you the product, which means based on the product you selected and based on your nature. If I am a software engineer, based on my nature, it will be showing the relevant product. So immediately the analytics happens in the backend and it is showing the result, right? So again, a separate analytics backend would be running and showing me the recommended products. So yeah, even in this case itself, you have saw multiple databases has involved, right? And of course, all my behavior data, where in what time I have logged in, where I have logged in, and how long I stay, and which all pages I have access. All this information will be stored into some data lake. Okay, so in this picture itself, we have crossed all these three types, like database, data warehouse, and data lake, right? So I'll go back and switch to the next thing. So when it is just database itself, again there are multiple options. The most popular storage model of database is relational database, which we all peculiarly use, like MySQL, PostgreSQL, SQL Server, and all those things. And there are few other storage models as well. As you see here, there are key value storage model, which is nothing but the caching database structures like Redis and all those things. And document oriented, which is nothing but MongoDB is a very typical example. And graph database, Neo4j would be a best example. And column oriented, options like HBase and Cassandra, right? So we for this time purpose, I cannot dive deep into all these different types, but I'll just talk about the relational and document oriented database alone, because that would be the mostly used databases for a product, right? So let me just quickly differentiate what a SQL database is and NoSQL database is. In SQL database, you will try to normalize as much as possible. Okay, what normalization means? You will split the table and have the data to be stored just once. You'll not store the data more than once if it is a SQL database, right? Why such a kind of architecture was the base for SQL databases? Because before 30 years or 20 years, the storage was not cheap. As you all know, to store 1 MB of data, it was costing around thousands of dollars, but not now. Even you can have terabytes of data in a very cheap manner, right? So, but since SQL was designed at that time, so it was designed to be storage cost efficient. Okay, so when we go for a SQL database, we will normalize our data model into different things. That's why we call it as fact table and the other set of tables. So where we'll be having primary key, foreign key, and all those things, and we'll be having the schema structure like star schema and all those things. And on the other hand, NoSQL, which doesn't have schema, which we need not have a fixed schema. You can easily change the schema, and it will not be a kind of denormalized. So it will not be a normalized structure, right? You will have different tables, and the data also will be stored in more than one place. Okay, so in this case, it is on the application layer to take the responsibility that the same data gets stored in all the tables. Okay, for example, the customer's data might be in more than one table. If I change the address in one table, it is the application's responsibility, which uses NoSQL database, to update the same address in all the tables, right? So simply say, in SQL, mostly there won't be duplicate data. In NoSQL, there will be the same data will be stored in multiple tables, because the structure will not be in a normalized fashion. But few things which are common is both will be having entity relationship diagram. That is primary key, foreign key relationship, and both will be having the access pattern and also index pattern as well, right? So few people think that only in SQL entity relationship diagram, this access pattern, indexing, and all those will be there, but it is not so. Even in NoSQL, it will be there, but to some extent we can have something like that. But the main crux of NoSQL database is it need not be in a very strict schema, right? So that is the main thing. So on very top of a top layer, you just need to decide what type of data you're going to have. Okay, where either it is structured, semi-structured, or unstructured. That basic knowledge we definitely need to have. Structured is nothing but rows and columns. Semi-structured is nothing but JSON and XML. Unstructured is nothing but images and video files. Okay, so who is going to use the data? Use that data? Is it going to be internally used, or is it going to be external customers are going to use, right? So that is one thing. And the next thing is, are we okay to go with choosing open source database as well, or are we is our selection need to be very closely cloud provider agnostic? For example, if your company is very strict around one cloud provider, obviously you might not be able to choose another cloud provider, right? So you just need to have these clarities in mind, and uh, have that mindset before you decide to choose a specific database. So, and this is another major division, like which we all need to know why choosing a database is OLTP and OLAP, online transactional processing and online analytic processing, right? So in these two categories, different databases are there. And let me just explain the characteristics of OLTP and OLAP. So when it's OLTP, it will be store the data in a raw format. Okay, that would be mostly the operational data. Okay, what I mean by operational data is the current data which which is essential for that product to run. For example, again, let's take the example of Amazon itself. Consider that I'm using Amazon for 20 years or 10 years. If it is in OLTP database, it should definitely have the details of my historical purchase of at least 6 months back, and it should be knowing my delivery address and all those information, right? So all this information should be stored in an OLTP database only. When it comes to the same Amazon.com for OLTP database, it the all the purchases beyond 1 year, like 5 years back or 10 years back, all these data is important for me, but not always, right? So for any rare circumstances, I may need the data. So in that case, all those historical data will be moved from OLTP and stored into an OLAP database, and it will be stored in a columnar format. So in an OLTP, it will be more of both read and write. In an OLAP, it will be mostly only read. The write will be very rare. Okay, so that would be thing. Or the write would be only once. And the query pattern of OLTP would be mostly small set of records that would be fetched by a primary key, and the joins involved will be very simple, maybe one or two tables. Whereas in an OLAP database, large number of records will be aggregated, and aggregated, what I mean is the total will be calculated or average will be calculated, kind of thing. And the joins also will be very heavy with multiple var classes. Okay, means the var conditions. And the users of OLTP database will be the actual application developers. The users of OLTP database will be analysts, decision makers, or data scientists, those kind of people. And the providers, to name few, are SQL Server, MySQL, and Postgres. And OLTP means we have many options like Synapse Analytics, Snowflake, BigQuery, Redshift, and even Teradata, Vertica, all those things. So again, I'll have a quick break. Do we have any questions? Okay, I think I don't have. I'll go on to the next module. So next, let me talk about my use case at Kissflow, what our team has faced while choosing a database model. So just to quickly introduce about Kissflow, because okay, for example, let's consider there is a procurement team, and they'll create a workflow like like purchase request also. To simple example, we all would be doing the travel reimbursed request, right? So let's consider that there is a HR, and the HR is a business user. She doesn't know coding. The HR itself can build the travel reimbursement application using this flow, using this case flow. Okay, so as per our product nature, per customer data will not be very huge, but we have a lot of customers. Okay, so that is the nature of our thing. And the OLTP database which we use is MongoDB. Earlier we used MySQL, and as I told earlier, each customer's data will not be huge, but each customer will be having individual database. Okay, so and also I told that the business users will be building workflow apps on their own, right? So Kissflow will not have the control of schema or the workflow which the customer is building. The schema will be very elastic. It will be very changing based on the workflow app they are building. And I'll quickly show a demo how the app looks like, and that would be easy to understand. And when it comes to the OLAP, means the analytics layer, um, we explore multiple options. Okay, so when I talk, why this Kissflow again, why Kissflow needs an OLAP layer is the travel reimbursement form. Let's consider it is already built, and people have started to create requests, and the approval happens, and the amount gets credited to customer, the person who requested, all this happens. What happens, it need to be analyzed over last year or 2 years, and the travel reimbursement form will be having just the employee ID, right? The actual employee information need to be fetched from another data set. That, let's consider employee table. So there is a need to join multiple tables together to find one insight, right? So we clearly had the need to have the OLTP and OLAP layer separately. So we decided to have a dedicated OLAP layer, and for that we explored from end to end, database, data lake, data warehouse, even our own kind of custom data environment. But finally we went and choose with data warehouse. Okay, so I'll again explain uh, um, why we went with the data warehouse need. So as I told earlier, before it was MySQL, and for the to address with the schema changes, we chosen with the MongoDB database. And based on the customer size, customer number of customers, we were able to increase horizontally, right? And again, the flexible schema need was there, and of course, what to say? Yeah, we had that advantage of MongoDB to be the kind of embedded documents, and it was able to have the performance over the data, even it is 1 TB. The performance was very good. Okay. So let me just quickly show you a glimpse of Kissflow, how it looks like, so that it will be easy for understanding. So this is just a home page, and let me directly create an application. So it's just a button click, and then while I navigate into it, I just need to name the process. I get into a form builder page, and I just need to enter what are all fields I need. So once I just need the employee name, and I need a number field, which should be telling, okay, I don't need a number field. Let me choose a currency field, because it just mentions about the travel amount, and maybe I may need to add a text area to explain about the travel details. So like this, I can add as many fields, and I need to configure the workflow as well. So while adding a step, uh, I just want to name that who who should approve the request. So in that case, uh, I might select one or more person and just save it. And any user who submits the travel reimbursement request, it will directly get assigned to the respective lead, and that lead has to approve that request. So like that, I have configured the workflow, and once I click go live, the end user will be having a loop something like this. So I just need to enter the employee name, which is myself, and I mentioned that it is $100, and I mentioned that the travel details. So once I submit it, the request gets submitted to the to my lead, and both of these persons gets notified that okay, this is the person who submitted, and you just need to approve this travel reimbursement. So as you see here, I have created the form, and I have even defined the workflow as well, all in a couple of minutes, right? And again, if I want to add any other field, I can simply go and edit the form, um, to accommodate additional information, or even I can delete any of the field. So because a business user might not be sure about having the requirement at the very beginning stage itself, right? So even once again, if I push it to live, all the upcoming items will be asking for the additional fields which I mentioned. So clearly you can see that the schema is not rigid, and the application is not controlling the schema, only user is controlling, right? So when I want to query over the data, and I just need to have a consolidated layer where I'll be able to see all the requests submitted, and I should be able to filter it, and I should be able to join this travel reimbursement with some other table, because in this it is just Dinesh Kumar. It doesn't have any other information, which department, when did he join, what is his salary, what in which cadre he is, and all those things. So for that, I might need to join this travel reimbursement with other tables. Okay, so this is the typical need at Kissflow. So for this application to run, the MongoDB acts as the OLTP database, which is schema free, and for this reporting need and the report and analytics need, we clearly understood that we need a separate layer so that this OLTP database, which is MongoDB, doesn't get affected, and performance is not degrading for the user. Okay, so this is my use case why we went to choose a data warehouse instead of data lake or database, right? So yeah, this is any product will be having will be involved with multiple databases. Okay, that's what this image means. So no Elasticsearch is a NoSQL database, but it serves for the OLTP need, the applications needs. And uh, of course, the Snowflake is clearly an analytics database, so it will solve the analytics need completely, and it is equal to, right? So any product you go, it will be something like this, and you need to have a picture of some kind of some kind of picture like this before you change the database, or you choose new database for your application need. Okay, so now let me come to the next section of the talk. I think I have around 10 minutes. I'll quickly try to wrap it up. So in both these Azure Synapse Analytics and Azure Databricks, it solves a kind of analytics needs. But what is different in both of these things, right? So let me quickly address it. So when it is Azure Databricks, it is more kind of a data lake, even though it supports SQL query. You can do a join and all those things. It is kind of more of a data lake kind of architecture. The base will be data lake, okay? But when it is Synapse, it is more of a RDBMS, or database kind of architecture. Okay, so it is actually Azure SQL data warehouse, which was improvised to scale to address with the big data workloads as well. Okay, so that's what the Azure Synapse Analytics is all about. And it is completely bundled. For orchestration, you'll find the data factory within Synapse. For compute, you can create provision SQL pool or on-demand SQL pool. And to store, again, you can have the Azure data lake itself, or you can have the SQL database. And of course, you will be having an single studio where you can do all these things. And when it is Databricks, you'll have something like this. Like the data engineers, the data scientists will be involved much to write Python scripts or Scala scripts over the data in a data lake to get some insights. So this is what the thing. So both Synapse and Databricks will commonly have Apache Spark, but the difference is in Synapse it is open source. In Databricks it will be latest from Databricks. Okay, because Databricks is the one who created this. So the latest version you can find over there. It is same Jupyter notebooks where you can write the Python script. In Azure Synapse, it will be interact, and in Azure, it will be Databricks' own notebook, where it will be having additional features like real-time co-authoring, like 2-3 developers can write together, the co-work together, and the changes will be present real-time, and there will be versioning also. And you can access data from data lake in both the thing. In Synapse, you need to write SQL scripts. In Databricks, first you need to mount it and then only you can query. But in Synapse, it is directly you can query. When it is the compute separated architecture, you have SQL on-demand pool, and in Databricks, it is auto-scaling pool. I'll show you a demo of both the products. Close it down. So right now, I'm in a Azure Synapse Analytics workspace, where, as I told earlier, you will be able to see the categories. This is for in this you can create the storage bases. Okay, so you can create a new SQL database, or you can connect with uh, 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 existing SQL database that you already have somewhere. Okay, so both the options are there. And right now, I think here I have a database. Yes, I do have a table. And develop is nothing but the developer, right? The data analyst or data scientist will be writing a SQL query or a Parquet query. As you see here, it is just a normal SQL query. That is the data that it points to is over a data lake, a blob storage, right? If I run on this, uh, it will fetch the data from that data lake, and it will play in the SQL queries fashion. Okay, so and as you could see, I just mentioned the SQL query alone. This is the data. Okay, this is where the data is present, stored, the storage layer. But where's the compute layer, right? So the compute layer, I already have it one, which is built in serverless pool. Or if I can even create a new SQL pool uh, mentioning the performance. If I need to have a better performance, I just need to select the performance level to be higher, where it is calculated in terms of DW, and I just need to name the SQL pool's name here. So as of now, I don't uh, I don't choose another SQL pool. And if it is a data, what is a big data kind of thing where Apache Spark is needed, I can create the Apache Spark pool as well here. I should name my Apache Spark pool, and which node size I need the environment, and in whether it should auto scale or it shouldn't auto scale. I can choose that. If it is if I choose auto scale, I can easily select the number of nodes. From minimum, it should have 3 nodes, and maximum it can have 51 nodes. Means if there is more number of requests come into the picture, additional nodes gets increased. By default, 3 nodes will be switched on, and you'll be having 274 rupees. If it is running 18, all 18 nodes are running, then per hour it will be billed around 1646. That's what this cost means. And so this is what the compute is going to be. And integrate, you can easily integrate with multiple sources, kind of thing. So Same way, if I come to the Databricks, this is how the Databricks looks like, where you need to create a cluster. Again, cluster is nothing but you need to create the compute environment. While you're creating, you need to choose that whether it is a standard or a single node is enough, or it should be high concurrency. Usually the production workloads will be on top of a high concurrency node. Usually if it is a dev environment or POC, it is a single node. Okay, standard is something, what to say, if you don't have a choice, or if you don't know which one is needed, you can choose standard. And of course, you need to choose the runtime over which Spark version, over which Scala's version you need. You can simply choose that. If it is a ML workload, you have a different set of selection. If it is standard, different, because this option is nothing but selection of GPU and CPU. Okay, so as you see here, you'll have the options for GPU, whereas if it is standard, you don't want to choose a GPU. It is waste of cost. So that's why they have clearly separated it. And once again, if you selecting the auto scaling, you can select the minimum and maximum number of workers, and you can simply create a cluster. Okay, so once you create the cluster, you under workspace, you can create notebooks, and you can write the Python scripts and play over the data. So I'll once again go back to the slide deck. So what I would say as the end goal of a data architecture is try to reduce the data getting copied from one system to another system as lesser as possible. Okay, so it reduces the chaos, and reduces the maintenance cost as well, right? And even it is unknown, just see that whether the chosen database solves the customer's need, and it is not that we have the set of people or our team already knows. Okay, so that's a general thing. And of course, have your base as flexible as possible, so that you can choose wisely, right? Choose your direction to go ahead wisely. And these are few resources which help me a lot to learn better about all these paradigms in deep, why it is there, how it is created, and all those things. So, and that's it. Thank you, guys. And if you have any questions, feel free to ask. Okay, Balaji has asked, like, Kislo app is available as mobile app. How do you manage to define different layout for web client? So I think that is more of a front-end question, but even I can answer that. Uh, the front-end portion of the mobile app version of Kislo, they have designed it as a PWA fashion. They don't have a separate code architecture for Android and the Apple base. They have designed it as a PWA fashion, so it is just for write once, and the deployment will be working over what to say, in a web app, and also in a mobile app as well. Okay, so when to select Synapse against Databricks, I'll once again show that. Due to the time constraint, I quickly skip that portion. This is how. So both of them have the same features. As I mentioned earlier, both of them have Spark. In both of them, you can create the compute architect, that Spark architecture. But when you can choose is, if you have the ad hoc data lake discovery, you can simply choose either Synapse or Databricks. If it is more of SQL based analytics, and it is more of data warehousing need, then you can directly choose Synapse. If it is a self-service business intelligence or reporting need, you can choose Synapse. And if it is like what to say, there will be same data. Both the data scientists need to play via Spark, and data analysts will need to play via SQL, and BI people, the business intelligence people need to play via Power BI. then it's better to choose Synapse. Even though Databricks supports it, it's better to choose Synapse because it is more user friendly, and it can satisfy different categories of people, right? And definitely, if it is of more of machine learning or AI development needs, if it is of GPU intensive task, then definitely go with Databricks. If it is of Spark heavy dependent, or the data you store is in different formats like Parquet, Avro, or Delta Lake format, then definitely go with Databricks. So this would be my suggestion when to choose Synapse over Databricks. Okay. And Balaji has asked that when data is stored in OLTP database, there could be sensitive customer data. How do you manage GDPR requirements, say in Europe markets? We'll have separate hosting, Balaji. Like uh, we'll maintain the OLAP and OLTP database for Euro customers in Europe. So we'll not be switching it between different things. And of course, the sensitive data, uh, in most cases, the sensitive data will not be moved into a OLTP database because it is not necessary as well. The sensitive data will be masked. If it is a credit card and those kind of information, it will be completely masked, and nobody will be able to see that what the data is actually. It will just have a column that this customer has a credit card. That's all, but it will not show that the credit card number or kind of details. Okay, Akshat has asked the question. We can do the same thing with Power Apps. What makes different in Cashflow? It's again the same parity. Under this the workflow automation sector, there are multiple apps are there, and Kissflow is one of the app. So Power Apps is another. And like Power Apps, like Kissflow, there are many other tools are there. Like the choosing again becomes based on the company. Like if they are a Microsoft heavy company, then they'll choose Power Apps mostly. Or if it is a company like where there are more business users are involved, and uh, it should be very lightweight, like it should be very user friendly to understand, then few people might choose Keysflow. It's again different tools are there. That's all. Yeah. So if there is no question, we can end the call, I hope. Yeah.
You can always reach out to Dinesh later if you have any questions. I think the QR code, you can scan the QR code, and that's his LinkedIn account. And yeah, you can always reach out to him. And I'm just displaying today's Learn module link and the survey link. So please feel free to share your feedback about today's session. Use the event ID, which is 16132, and let us know how did you like today's session. Thank you, Dinesh, so much for the session, and thank you all for joining us today. Also, please join Microsoft Reactor Bengaluru meetup page for more upcoming session. Thank you all once again, and enjoy the rest of your day. Thank you.